Hey guys, so for this video, what I'm going to try to do is I'm going to try to get through half of the review sheet today, and then I'm going to try to get through half of the review sheet in the next video. All right, so let's go ahead and start with question number 1. We're just going to do the odds today. So we have cosine of x is equal to radical 3 minus cosine of x, and it even gives me a little hint here. It says collect like terms. So what I'm going to do, I'm going to put all the cosines on one side, and then I'm going to put all the numbers on the other. So if I subtract, I'm just going to add, why not? I'm going to add cosine on both sides, and I'm going to add cosine on both sides, and so I'm going to get 2 cosine of x, and I'm going to subtract radical 3. Subtract radical 3. So I'm going to get negative radical 3 here, divide by 2. And so I get cosine of x is equal to negative radical 3 over 2. So on my unit circle, what I'm really asking is when do I have an x value of negative radical 3 over 2? Well, that happens here, and it happens here. It happens at 5 pi over 6. Sorry, sometimes I have to remind myself. Happens at 5 pi over 6. And then it also happens at 7 pi over 6. So let's go ahead and write these down. So I'm going to get, and it doesn't say that there's any, it doesn't give me any interval. So this is going to be 5 pi over 6 plus the period, which is 2 pi n. And it's also going to be 7 pi over 6 plus the period, in this case, which is 2 pi n. All right, let's go ahead and do the next one here. All right, so number 3. 2 cosine theta sine theta is equal to cosine theta. It gives me a hint, factor out a greatest common factor. Well, to do that, I'm going to get everything equal to 0 first. So we're going to say 2 cosine of theta sine of theta minus cosine of theta is equal to 0. Okay, so if I factor out a cosine theta, what's left on the inside? A quick way to remember how to do that, divide each term by cosine theta, see what's left. That's going to be 2 sine theta divided by cosine theta. That's going to be 1, so minus 1 is equal to 0. Well, at this point, I have the zero product property. I have something times something is equal to 0. So I'm going to set both pieces equal to 0. Remember that the zero product property does not work when you don't have 0. That's why it's called the zero product property. All right, so 2 sine of theta minus 1 is equal to 0. When does cosine of theta equal 0? Well, cosine of theta is equal to 0 at pi over 2, and it's equal to 0 at 3 pi over 2. And you can check that on your unit circle. This one, if I solve this, I'm going to get sine of theta is equal to a half. So where does sine of theta equal a half? Might want to pull my unit circle up for this one. Basically, this is saying, hey, where do I have a positive y value of a half? Happens at pi over 6. It happens at 5 pi over 6. So pi over 6 and 5 pi over 6. So to answer this generically, what I can say is pi over 2 plus the period, which is 2 pi n, 3 pi over 2 plus the period, which is 2 pi n, pi over 6 plus the period, which is 2 pi n, and 5 pi over 6 plus the period, which is 2 pi n. 2 pi n. If you wanted to be really fancy here, if you really wanted to, what you could do is you could reduce this a little bit. So you really can't reduce it too much, but you could reduce these two. Reason I know that, if I have pi over 2 here, and I have 3 pi over 2 here, a quicker way of writing pi over 2 plus 2 pi n and 3 pi over 2 plus 2 pi n is just to write one of them. If I just wrote pi over 2 plus pi n, that would actually cover everything, because I would start at pi over 2, I would go over n, pi n, which would take me to 3 pi over 2. From 3 pi over 2, I'm going to move another pi, which would take me back to something bigger than 3 pi over 2, which would be 5 pi over 2. So this is actually the easier, more generic function. You probably saw this on like a WebAssign, and that would actually be, if you did that on like a quiz, I would give you some sort of extra credit. But obviously be careful with that, because if you answer wrong, I would have to take off. So it's a little bit of a risk there. If you want to be safe, just write your 4 answers. All right, let's go to the next question. All right, it says, and thankfully for us, it's giving me a hint. It says 3 secant squared x minus 2 tangent squared x minus 4 equals 0. Rewrite with a single trig function. All right, well, what might be helpful is to have my identities next to me. The most important identity here that I think I'm going to use is going to be the Pythagorean identity. I want to get everything in terms of one trig function. Well, if I look, just because I'm lazy, I want to pick the easiest thing. I already know what secant is. I already know what secant squared is. Secant squared is 1 plus tangent squared. So I'm going to replace it. So 3 times 1 plus tangent squared x minus 2 tangent squared x minus 4 is equal to 0. So if I go ahead and distribute the 3 out, I get 3 plus 3 tangent squared x minus 2 tangent squared x minus 4 is equal to 0. Well, let's just combine some like terms. 3 tangent squared x minus 2 tangent squared x is positive 1 tangent squared x. 3 minus 4, hopefully that's easy as negative 1. So the question is, when does tangent squared x equal positive 1 if I move this over? Well, the only way to undo a square root is to take the plus or minus square root. So we're going to take the plus or minus square root. I want to know, when does tangent of x equal plus or minus 1? So basically, when does it equal negative 1 or 1? Well, tangent of x is going to equal negative 1 and 1 anytime I have a value that is divided by 4. So that's pi over 4, 3 pi over 4, 5 pi over 4, etc. So we can say generically, x is equal to pi over 4 plus the period, which is pi n, and then it's equal to 3 pi over 4 plus the period, which is pi n, 5 pi over 4 plus the period, which is pi n, and 7 pi over 4 plus the period, pi n. Okay, this one, the same thing. If you did want to simplify this and make your answer easier, technically pi over 4 plus pi n gets me to 5 pi over 4. So I actually don't need this answer. And 3 pi over 4, if I add pi to it plus pi n, gets me to 7 pi over 4. So actually I don't need that one either. So if you wanted to be really simplified here, technically it's just these first two. All right, let's move on. Number 7, using multiple angles. So what I'm going to do here, I'm just going to move everything to one side. So I get sine of 2x is equal to radical 3 over 2. I don't know very much of sine of 2x, but I know a ton about sine of x. So I'm going to actually replace 2x with j for Miss Johnson. So we're going to say sine of j is equal to radical 3 over 2. So what I really want to know is, when do I have a y value of radical 3 over 2? That happens here. It happens here. It happens at pi over 3, and it happens at 2 pi over 3. And so j, generically speaking, j for generic, no, that's actually a g, is going to be pi over 3 plus the period, which is 2 pi n, and 2 pi over 3 plus the period, which is 2 pi n. But I'm not solving for j. I'm solving for x. So what I want to do is replace j with what it is. J is 2x. So we're going to say 2x is equal to this whole thing. It's equal to pi over 3. It's equal to pi over 3 plus 2 pi n. And it's equal to 2 pi over 3 plus 2 pi n. All right, so all I need to do is solve for this. I'm going to multiply by a half on both sides. If I multiply by a half on both sides, that will get rid of that pesky. I don't know. Well, pause the video. You guys tell me what word I'm trying to think of here. All right. If I multiply by half on both sides, I'm going to get rid of x here, and I'm going to get, pi over 3 times a half is pi over 6, plus 2 pi n divided by 2 is just pi n. And pi over 3 times a half is the same thing as pi over 6, which actually is the same thing as pi over 3. Plus 2 pi n divided by 2 is going to be pi n. And so this right here is the generic equation, and I actually can't make it any more simple than that. All right, next one. I just want to solve for all possible values in radians. Okay, actually for all of these, I would prefer radians. I know that first question had degrees. I actually meant to correct that. I just forgot about it. All right, so for this one, 2 sine squared theta minus sine theta minus 1. This looks like a factoring question. I'm going to factor this. 2 times something squared plus something minus 1 is equal to 0. So I want to know, can I basically factor this? So if I said 2 sine theta, in fact, the way that I usually start factoring is I I start with the first term. Usually there's only two options for the first term, which there are in this case. Sine theta can only be factored into 2 sine theta and times sine theta. And I want the middle term to add to 1. So I'm going to say plus 1 here, minus 1 here. Those are the factors of negative 1. And if you multiply that out, you will get the solution. And if you wanted to, you could also use box method with your x, and that's also going to work. All right, I'm going to set both pieces equal to 0. So 2 sine of theta is equal to 1, and sine of theta is equal to negative 1. If I solve this a little bit more, sine of theta is equal to a half. So I just want to know on my unit circle, when does sine of theta equal a half? Okay, well that's going to be when my y value is a half. So that happens at pi over 6 plus the period, which is 2 pi n. 2 pi n. And it happens at 5 pi over 6 plus 2 pi n. When does sine of theta equal negative 1? Well, that actually only happens once, and it happens at pi over 3. So we're also going to say that theta is equal to 3 pi over 2. I'm sorry, I said pi over 3. 3 pi over 2 plus the period, which is 2 pi n. All right, so those are the solutions there. Okay, so let's move on to the next question. All right, so the next question, 7 tangent of theta is equal to 3 radical 3 plus tangent of theta. I would go ahead and combine like terms on this one. So I'm going to subtract tangent of theta on both sides. So I get 6 tangent of theta is equal to 3 radical 3. Divide by 6, divide by 6. And so what I want to know is when does tangent of theta equal radical 3 over 2. All right, so go ahead and take a pause here, see what you get. All right, so if you're trying to find this value on your unit circle, you're probably not going to find it because tangent of theta on the unit circle could only equal radical 3 or radical 3 over 3. And so what we're going to do here is we're actually going to break out our calculators. So in order to solve this, we could go on Desmos, or we could take the inverse tangent on both sides. I'm going to take the inverse tangent on both sides. So I'm going to get that theta is equal to whatever the inverse tangent of radical 3 over 2 is. Now real quick, I'm just going to make a really quick sketch of what I think the answer should be. So if tangent is positive, that means my first answer has got to be somewhere here. And if tangent is positive, I also know that my answer is going to be somewhere here. And the reason I know that is all students take calculus. Tangent is positive in the first quadrant and in the third quadrant. So if I have some value of something divided by something is radical 3 over 2, that's going to happen in the first quadrant. And then if I take the same thing divided by the same thing, but both are negative, like in the third quadrant, that's also going to yield my solution. So let's get my calculator out. Unfortunately, I don't think that my calculator is going to show up on your screen because of just Screencastify stuff. So I'm going to just kind of screenshot it for you. So inverse tangent of radical 3. And remember, make sure that you're in radian mode. We're answering in radian, so I want you to be in radian. So say second square root. All right, so the inverse tangent of radical 3 divided by 2. And I'm just going to go ahead and screenshot that and put that on the screen so you guys can see. Okay. All right, let me paste that in. All right, so this is what I'm seeing here. All right, so we get what looks like 0.713. And so I know my first theta value is going to be 0.713. And so now I just need to find out what my other value is. So really, 0.713 is the blue angle here. 0.713 is the blue angle. What I'm looking for is what's the yellow angle. Well, to get the yellow angle, I'm going to go an entire pi, and then I'm going to go an additional 0.713. And so to find the other angle, I'm also going to have pi plus 0.713. So if I say pi plus 0.713, hopefully my calculator is still up, so we'll just say that same answer. Plus pi. And we're going to get 3.855. So we also, for this one, get 3.855. All right, so then to write this generically, all I'm going to do is add the period times n. So we're going to say 0.713 plus the period of tangent is pi n. and 3.855 plus the period times n. And that right there is the solution using my calculator. All right, let's keep going. 2 cosine of theta minus 1 is equal to 0. Let's go ahead and add 1 to both sides. So 2 cosine of theta is equal to 1. So when does cosine of theta equal a half? Okay, well, that's pretty standard question here. Cosine of theta is going to equal a half here, and it's also going to equal a half here. So we'll say theta is equal to pi over 6 plus the period 2 pi n, and it's equal to 11 pi over 6 plus the period times n, and that right there is the solution. All right, next one. Secant cosecant theta plus 2 cosecant theta is equal to 0. What I'm going to do is I'm going to factor out something that I see in common, cosecant. So cosecant of theta times, okay, well, to know what's left, I'm going to divide by cosecant. So what's left has got to be secant theta, divide by cosecant, and I'm going to be left with radical 2 is equal to 0. All right, well, let's set both of these equal to 0. Cosecant of theta, this is using the zero product property, is equal to 0. And secant of theta plus radical 2 is equal to 0. All right, so when does cosecant equal 0? Let's think about this for a minute. What this is saying is when does 1 over sine theta equal 0? Okay, I'm going to graph it real quick. I'm going to paste it up onto the screen. Okay, so let's go and put the graph of secant up onto the screen. Hopefully you remember this, but if you don't, you have a graphing calculator. Well, if I take a look at the graph of secant, I'm seeing that the graph of secant never crosses the x-axis. If something never crosses the x-axis, that means that it's never equal to 0. Why in the world would this never be equal to 0? Why would 1 over sine not equal 0? In fact, why are there these asymptotes here? So hopefully you guys remember that day that I taught you guys about the secant and cosecant function. The reason that I have these asymptotes here is because if sine of theta is equal to 0, I get an asymptote. I get 1 over 0. In fact, we kind of proved the other day that 1 over 0 is undefined. If I use that first proof, it must be infinity and negative infinity at the same time, which does not compute. And so when I have cosecant of theta is equal to 0, in fact, you could even take the inverse in your calculator, you would see that you would get an error. There's no way to make cosecant of theta equal to 0. And so we can say that this value is the empty set. It doesn't exist. You can write either of those. So we're going to go ahead and just focus on the second piece here. So we have secant of theta is equal to negative radical 2. I want to know when does secant of theta equal negative radical 2. Okay, well, I could answer this in my calculator, but I'm still going to have to do the same thing. What I want to do is I want to write this in terms of its reciprocal. So I'm actually allowed to take the reciprocal of both sides. The reciprocal of secant is cosine theta. The reciprocal of negative radical 2 is negative 1 over radical 2. Okay, if it's still not ringing a bell, I mean, obviously you guys can look on your calculator, but if it's still not ringing a bell from your unit circle, let's rewrite it. Let's rationalize it. If I multiply by radical 2 over 2, that rationalizes it. I get negative, in fact, I guess I should keep room for next time. I'm going to get negative radical 2 over radical 2 times radical 2 is 2. Well, that really rings a bell because I know that negative radical 2 over 2 definitely is on my unit circle. I see that all the time. Actually, radical 2 over 2, any iteration of it, always happens at something divided by 4. So it could be like pi over 4, it could be like 5 pi over 4. So when I have negative radical 2 over 2, I'm asking when do I have a negative x value? So that means I need to be looking to the left of my unit circle. When is x negative? That happens at 3 pi over 4. And you can check this. And it also happens at 5 pi over 4. And so I'm going to get that theta, generically speaking, is equal to 3 pi over 4 plus the period, which is 2 pi n, and it's equal to 5 pi over 4 plus the period, which is 2 pi times n being any integer. All right, let's keep going. All right, secant x plus tangent x equals 1. It says solve it on the interval. Oh, thank goodness. All right, so we're done with generic for a minute. All right, secant x plus tangent x is equal to 1. All right, so one thing that I could do here, because I don't have the same terms. So the first thing I usually look for is, hey, is there anything I can combine? Second thing I look for is there anything I can factor? Third thing that I look for is probably, can I get all the numbers on one side? Can I get all the variables on one side? I'm not seeing any of this. And so this one is kind of a unique case The only thing that I can really think to do to get these in terms of one variable is if they were squared. If they were squared, I could use a Pythagorean identity, which I would like to use. So let's go ahead and we'll square both sides. So I'm going to go ahead and square both sides, which is totally legal to do. All right, so secant x plus tangent x squared is equal to 1. You know what I'm really tempted to do, and I think I'm just going to write it, but I'm going to write it in a different color because it's not right. It's wrong. I think that secant x plus tangent x squared is just secant squared x plus tangent squared x. What's wrong with that? Well, what's wrong with that is I can't distribute a exponent over addition. So if I think about like the hierarchy of what's happening here, I have addition, subtraction, multiplication, division, and I have like powers up here. I cannot distribute across 2 tiers. So I could distribute a power if it was distributed across multiplication, totally legal. But if I try to jump 2 steps, I'm going to fall down the stairs and really hurt myself. So I really cannot distribute exponents across addition or subtraction because they're too far away. They're 2 steps away instead of 1. So do not do that. Think about the sweet, precious baby animals. This is on par with the whole baby animal situation. So what I really could do, if I never want to mess this up, is anytime I see a quantity squared, I could just say secant x plus tangent x times secant x plus tangent x. And it becomes way more clear here that that's not going to be tangent squared x plus secant squared x because I need to use distribution of binomials. I'm going to use FOIL method. This is going to be secant squared x plus secant x tangent x plus secant x tangent x plus tangent squared x. So we're going to go ahead and rewrite this. Using distributing of a binomial, I don't want this to be like that, we're going to get secant squared x plus, these are the same, so I'm going to say 2. In fact, anytime I multiply out a binomial, the same thing times the same thing, it's called a perfect square trinomial, and it always factors to something like this. A squared plus 2ab plus b squared. So if you ever catch me like looking like, oh wow, Miss Johnson, you did that really fast. It is not because I computed it very fast. It's because I had it memorized. So we're going to say 2 times the middle terms, which is secant x tangent of x plus tangent squared x. And I want to know this is equal to 1. Okay, so at this point, you still might be like, okay, I have no idea why we did that because I still don't see anything. Well, here's another thing. So if I think about things that I should do, in fact, I'm going to write this down. Some things that I should do. Things that I know are things that I can do. Well, some things that I can do. The first thing I always think to do is combine like terms. So the first thing that I want to do is combine like terms. Well, I can't really combine like terms at this point. I've done all of that. Next thing I can look to do is I can look to factor. I just did the opposite of that. I don't want to do that. So I'm kind of like trying to figure out what to do here. Well, most of these problems come down to this. Can you get everything in terms of one trig function? Can I? Well, let's go ahead and, in fact, I'm going to go back and copy and paste something. Let's see. Where is it? It was a while ago. Oh, wow. I'm going to copy and paste something because it might be helpful. Let's look at some identities and see if I can use any identities. In fact, specifically speaking, most of the identities we're going to be using are going to be Pythagorean. Well, if I take a look at the Pythagorean identities, wait a darn minute, I know that secant squared theta is equal to 1 plus tangent squared theta. If I replace that, that's actually going to be really helpful because then everything's going to have a tangent in it. So let's do it. Secant squared theta is the same thing as 1 plus, don't write like that, too big. 1 plus tangent squared theta, in this case x, plus 2 secant x tangent x plus tangent squared x. All right, let's go and combine some like terms. So tangent squared x plus tangent squared x is 2 tangent squared x. I have a plus 1 on this side and I have a 1 on this side, which means these are going to cancel. And then I have plus 2 secant x tangent x. At this point, I do see something that I can factor out. Tangent is what everything has in common, so I'm going to factor tangent out. So tangent of x is equal to, if I divide everything by tangent of x, what's left on the inside is 2 tangent of x divide by tangent of x, and I'm going to get 2 secant of x is equal to 0. So at this point, I could use the zero product property to solve at least one piece of this comfortably. In fact, I take the 2 out too. I'm going to take the 2 out. All right, so go and see if you could use the zero product property now to solve this. All right, so we can see that this first piece right here, 2 tangent of x is equal to 0. That one's not going to be too bad. So we want to know, hey, when does 2 tangent of x equal 0? If it's going to let me write it. When does that equal 0? And then I also want to know, when does tangent of x plus secant of x equal 0? Which is going to still require maybe a little bit more work from us. All right, so when does tangent of x equal 0? In essence, I can divide this 2 out. I just want to know, when does tangent of x equal 0? So what I'm going to do, take my unit circle, see if I can do anything good with it. All right, I'm actually going to erase because I need a little bit of space here. Hopefully I can fit everything in here. All right, so when does tangent of x equal 0? Well, I remember that tangent is y over x. So I'm really just looking, hey, when does y equal 0? Because if x equals 0, we are in trouble. That is not something we want. So when does y equal 0? Well, that happens here at 1, 0, and it happens here at negative 1, 0, which is 0 and pi. So we can say at this point x is equal to 0, and it's equal to pi. And remember that we're doing it on the closed interval. So we're just going to do those answers. We don't have to do anything else generic. All right, last thing I want to solve, when does secant x plus tangent x equal 0? Well, at this point, unfortunately, I can't think of much more except to try to combine like terms. Well, the only thing I can think to do here, because I've already used the squaring method. If I use the squaring method again, I'm going to get the same result. I don't really want that. So what I'm going to do is I'm going to write it in terms of sines and cosines. Tangent is the same thing as sine x over cosine x. And secant is the same thing as 1 over cosine x. So I want to know, when does 1 plus sine x over cosine x equal 0? Well, really, I can kind of forget about cosine x equaling 0, because if cosine x is equal to 0, then this whole thing is going to be undefined. So really, all I care about is, when does the numerator equal 0? So when does 1 plus sine x, when does it equal 0? Well, that's when sine x is equal to negative 1, which happens here at 3 pi over 2. Happens at 3 pi over 2. And so I can get that x is equal to 3 pi over 2. But what I want to do now is I just kind of want to check and make sure all of these answers are making sense given the situation. So really quickly, let's just go ahead and make sure that all of the answers make sense. So if I plug in 0 to the original, I get secant of 0, which is 1 over x, 1 over cosine. So cosine of 0 is 1. That works. Okay, so I get 1. Tangent of 0, once again, tangent of 0 is going to be y over x, which is 0 over 1, which is 0. That works. Tangent of 3 pi over 2. Tangent of 3 pi over 2. Let's think about what the coordinates are on that. That's going to be 0, negative 1. If I try to evaluate tangent of 3 pi over 2, I'm going to get something that doesn't exist. In essence, at 3 pi over 2, tangent has an asymptote. It doesn't exist because it's y over x, and negative 1 over 0 doesn't exist. And so that right there is actually what's called an extraneous solution. If I check it, it actually doesn't exist. In fact, pretty much anytime I'm dealing with a tangent function or some function that has an undefined area, like an asymptote, you might want to check for extraneous solutions, because in this case, while I did solve and get 3 pi over 2 as a solution, it's not actually a solution, because I cannot have a piece where, I cannot have a part where when I plug it back in, I get part of the asymptote. And so my only answers here are actually 0 and pi. All right, let's keep on going. All right, 2 sine x plus 1 is equal to cosecant of x. What I might do here, if I'm thinking about things that I can do here, I might write this one in terms of sines and cosines, see what I can do. So I have 2 sine x minus cosecant x plus 1 is equal to 0. If I write this as 2 sine x minus 1 over sine x plus 1 is equal to 0, I could get everything in terms of sine x in the denominator. So if I multiply everything by sine x, I get 2 sine squared x minus 1 plus sine x, and that's all over sine x. So I just multiplied everything by sine x. And I know I'm kind of skipping some steps here, but this video is quite long, and I would like it to be done pretty soon. All right, so I'm going to try to factor this. So I'd get 2 sine squared x plus sine x minus 1 is equal to 0 all over sine x. Once again, I don't want sine x to equal 0 because if sine x is equal to 0, then this whole thing's undefined. So really what I want to set equal to is I want to set the numerator equal to 0. I want to set the numerator equal to 0. So we're going to say 2 sine squared x plus sine x minus 1 is equal to 0. So I'm going to go ahead and factor this. We've already actually factored this earlier. So we're going to say 2 sine x plus 1 times, we'll say minus 1, times sine x minus 1 is equal to 0. So I want to know basically when does sine x equal a half and when does sine x equal 1. Okay, well sine x is equal to 1 at 3 pi over 2. And sine x is equal to a half. Sine x is equal to a half here and here, so pi over 6 and 5 pi over 6. All right, just to be clear, I want to make sure that none of those values yield a 0 in the denominator. They can't because the only denominator I have is sine x, and all of these values don't give sine x a value of 0. So this right here is the solution. This is the solution for x. All right, 2 sine squared x minus sine theta is equal to 3. This is a factoring question. So 2 sine squared theta minus sine theta minus 3 is equal to 0. If I factor this, this is going to be, let's see, 2 times 3. Let's do this. 2 sine of theta plus 1. Let's see. And sine theta. All right, so if I put the 3, let's see, we'll put the minus 3 here. We'll put the plus 1 here. All right, sometimes it just takes a minute to do this. You obviously could use box method here. I'm just trying to save just a little bit of time. All right, so I think that this one is going to work. Yep, that should give me a negative in the, yep. All right, so what I'm going to do is go ahead and solve this generically. So using zero product property, sine theta is going to equal 3 over 2. And using zero product property, sine theta is going to equal negative 1. Well, sine theta equals negative 1. We already talked about this at 3 pi over 2. So I want to know when does sine theta equal 3 over 2? Well, that right there is going to be a calculator question. It's not on my unit circle. So when does sine theta equal 3 over 2? I just want to know, okay, when does sine of theta equal basically 1.5? Wait a darn minute. I thought that the range of sine was from negative 1 to 1. That's bigger than 1. And so that is actually an extraneous solution. That solution does not exist. And so the only answer here is going to be 3 pi over 2. All right.